Now, what will be the actual size? Now, every day you are doing practical. कळलं तुमका आता एक पर्टिक्युलर साईड दिलेली असतात जी तुम्ही आता फिनिशर केले आणि ज्यांना तुम्ही फायनल फिनिश करून येता पाहिजे त्यांना मेजर करता पण दॅट इज ऍक्च्युअल साईज. तुम्ही ऍक्च्युअल प्रोड्यूस करून जी साईज जाता पण तेका आमी ऍक्च्युअल साईज. दिस इज क्लियर. आता कसल्या साईजीत देर इज अ टॉलरन्स प्लस और मायनस किती असतात. हा 3 ते 4 असलेला आता तुम्ही 3 ते 4 वेळी तुम्ही 3.3 मिळवा within tolerance 3.3 जो मिळाला पण ऍक्च्युअली अवेलेबल साईज लास्ट जॉब जाता पण तेका आमी ऍक्च्युअल साईज. कळलं. पेपर एक साईज असता. You are doing one according to that size and to finish certain job it's at the point then measure the point that is your actual size. Right? See, it is the size of the component by the actual measurement after it is a manufactured. तुम्ही तयार करतो रे. So तुम्ही जे daily job करता पण you are manufacturing. काय म्हणून तुम्हाला that's what pay attention here, don't try that. It should be lie between the two limits of the side. ते केतु बिल दोन जे लिमिट येतात पण अप्पर लिमिट लोअर लिमिट असता तेतू भितर असतो. It should lie between the two limits of the side if the component is to be accepted. कळलं. त्या दोन्ही भितर असल्यास ते accept करतो. आता एव्हरी डे तुम्हाला त्याच्या मुखात जॉब करतले त्यांना ते टॉलरन्स हा ते 5 पडे आणि जी तुमचे साईज आपण विदिन दॅट टॉलरन्स दाखवलं पण लिमिट लोअर लिमिट त्याच्या भितर आला इट इज एक्सेप्टेड अदरवाइज नॉट एक्सेप्टेड. कळलं. फाल्यां तुम्ही प्रॅक्टिकल एक्झाम तुम्ही एनालिसिस जातले बेस्ड ऑन दॅट प्रत्येक डायमेन्शन मार्क्स ईच अँड एव्हरी डायमेन्शन तुमचे समज विदिन दॅट एक्सेप्टेड ना 10 मार्क्स आणले तुमचं डायरेक्ट 0 पडतो. कळलं. विदिन दॅट टॉलरन्स येलो जाल्यार तुका मार्क्स मेळटा. दिस इज अ ट्रेड यू कॅन स्कोर आउट ऑफ 100 सुद्धा घेवपाक जाता. कळलं. सगळं डायमेन्शन मार्क्स एक्युरेट विदिन दॅट टॉलरन्स केल्यार सगळे मार्क्स तुम्ही कोण काढू शकना. You have to get tick 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 right. फक्त राइटिंग वर किती आपण ओरल किती आपण तिंगा किती प्लस मायनस मायनस आहे. तर तुम्ही सगळे डायमेन्शन अकॉर्डिंग टू टॉलरन्स केले तुम्ही कोण मायनस करू शकता. कळलं. त्याचे तू डायमेन्शन तिथे जापाचे विदिन दॅट टॉलरन्स जापाचे ट्राय प्रॅक्टिस करू म्हणजे डेली प्रॅक्टिस करून ती स्किल इम्प्रूव्ह जाते. आता तुम्ही फर्स्ट जॉब केलो आणि आता जॉब केलो कंपेअर करा इफ देयर इज डिफरन्स हा मरे. सो एव्हरी डे असं तुम्ही करून इम्प्रूव्हमेंट हाडता. Don't waste your time. आता काय करना बसून आपण तुम्ही स्किल इम्प्रूव्ह करा तुम्ही डेली थोडी स्किल जातो ऍडिशनल स्किल घेवपाची वेल्डिंग टर्निंग शीट मेटल आणखी जातात ते अलर्ट अकॉर्डिंग टू ते तुम्ही बरोबर असाच. कारण वेल्डिंग एक मारो येवपाक सगळ्यांक. एव्हरी फिटर हॅज टू बी नो द वेल्डिंग प्रॅक्टिकल. कळलं मरे. सो नाव आता विदिन दॅट इट शुड बी लाई between the two limit of sizes of the component it accepted. So ये तो भीतर पडतो. आता ही एक लाइन दिली आहे that is zero line म्हणलेलं आहे किंवा बेसिक लाइन म्हणतात. हा this is hole and this is shaft. Drawing is now. आता this drawing is very important actually. आता एक किती ते तुम कळपाक जाय. This is a ABCD to learn the engineering. कळलं. इंजिनिअरिंग शिकता असताना this is a basic ABCD म्हणते पाशी. वो एक शाफ्ट दिलो. कळलं. एक शाफ्ट दिलो आणि एक झिरो लाइन और झिरो डेविएशन दिले आणि एक होल दिलो. आता होल आणि शाफ्ट मिळाले गेले. Our this system will all work on these two hole based system and shaft based system. दोन आमचे सिस्टम आहे स्टँडर्ड सिस्टम आहे. शाफ्ट बेसिस सिस्टम होल बेसिस. तर शाफ्ट बेसिस सिस्टम लागते. शाफ्ट डायमेन्शन असतात पण ते आम्ही स्टँडर्ड धरतो. ओके. आणि होल डायमेन्शन आम्ही चेंज करतो तेका आम्ही शाफ्ट बेसिस सिस्टम आणि होल बेसिस सिस्टम भितर होल डायमेन्शन आहे ते स्टँडर्ड धरताय. शाफ्ट डायमेन्शन चेंजेस करतो व्हेरीज करतो प्लस तेका आम्ही होल बेसिस सिस्टम म्हणतो. दोन सिस्टम असतात बेस्ड ऑन शाफ्ट बेसिस सिस्टम होल बेसिस सिस्टम. आता ही खूप टाइम असेल. वी हॅव मिनिमम डाया मॅक्सिमम डाया. कळलं. दिस इज रिलेटेड टू द होल बेसिस सिस्टम. या होल बेसिस सिस्टम दिले शाफ्ट डायमेन्शन कॉमन दिले. हिंगा तेका आम्ही अप्पर डेविएशन दिल्या नेक्स्ट लोअर डेविएशन दिल्या मागीर हिंगचे शेडेड पोर्शन कितें केले आपण एक टॉलरन्स म्हणल्या पयला दिसता तुमकां. हा सो टॉलरन्स मीन्स प्लस और मायनस ती डायमेन्शन ती हेतू भितर आसता. So upper deviation and lower deviation. This is in the case of what? Sharp bridge system. And whole bridge is whole bridge system of with inkit dilya minimum dia, maximum dia, basic size and inga low tolerance dilya setting. So this is a tolerance, lower deviation, upper deviation. This is the case of whole bridge system. Right? Whole standard असतो shaft very simple. आता आम्ही एक एक शिकूया. So limits of size. These are the extreme permissible sizes within these are the extreme permissible sizes within which the operator accepted to make the component maximum and minimal limit. और सदाच जो operator आपोय तो within this limit के ऊपर try कर. Now what is the minimum limit of size? It is the greater of two limit size. Minimum limit of size, it is the greater of the two limit size. The minimum limit of size, this means some problem. This is not correct. Minimum limit, it is the greater of the two limit size. This is the maximum limit of size. If a basic size, this is the basic size, and the shaded upward that is called tolerance. And from this zero line to top portion of the upper deviation, right? And from this line, shaded line, circle line to this basic line, the lower deviation. A drawing could understand correct, right? Basic size. Minimum limit of size that is here from this. Okay, this is the minimum limit of size from this to this, and maximum limit of size up to this. You can allow to produce any component from this portion to this portion, which is acceptable. Beyond the upper limit, maximum limit, it is not acceptable. Correct? And beyond the minimum limit, it is also not acceptable. So, talk this is a tolerance of shaded portion of the tolerance. This is your basic line. This is fundamental. This is called fundamental deviation, and this is a zero line, and this is a tolerance. So for the any component, this chart pair, serial number 1, size of the component is 20 millimeter. 20 is a basic size. Correct? So 20 is a basic size, or you can say zero line. Minus 0.005 is a lower limit. Right? You can allow up to minus 0.005, and plus 0.008 is a upper limit. So 20.008 millimeter is allowed, and 19.99 what is the 995 is lower limit. So only that you can allow. Correct? So kitli barik आप find. Take the precision measuring instrument is need to be reading proper within the tolerance. So micrometer, vernier caliper, digital vernier caliper, सगळं read करून ते measure करता. Now here no 1 millimeter, all in decimal. So upper limit and lower limit कितले आहे? Same this. आता हेतु भीतर upper deviation कितले आहे? Plus 0.08 आहे. Lower deviation minus 0.05 असा. Okay. Then maximum limit of size असा. Oh, thank you. Correct? Maximum limit of size is 20.008 and minimum limit of size is 19.99. So second, another example is given, that is 20 is a basic size. Upper limit is plus 0.28. Lower limit is also plus 0.07. Correct? But 20 chap where much all is pass. 20 chap 19 in this case. This is another case. So there is upper deviation, lower deviation again is given here. Maximum limit is 20.028 and minimum limit of size is 20.007. Third example is given for the 20 same basic size they have kept. Okay. But here the both limits are in minus. Upper limit is also minus 0.12 and lower limit is minus 0.21. So upper deviation is minus 0.012, lower deviation is also minus 0.021. So maximum limit of size is 19.988. Exact 20 pound and 19.9979 is the lower limit. So here दोन्ही भीतर केला top product is passed. What is the hole and what is the shaft? In the Bureau of Indian Standard, the system of limit and fit all internal features of the component, including all internal features of component, including those which are not cylindrical, are designated as a hole. But all internal shaft hole असतात. आता rectangle एक slot असा. Basically dimension they are followed by the whole system. Bearing. Housing, bearing muscle housing all the internal dimension kita there come under whole system. But also, as per the Bureau of Indian Standard System of Limited with all internal features of the component, including those which are not cylindrical. And mostly whole build cylinder but not cylindrical. You know, rectangle, square also hollow will the internal dimension we consider in the whole system are not cylindrical designated the whole system. And now for the shaft system, in the Bureau of Indian Standard, the system of limit and fit all external features of the component, including those which are not cylindrical, are designated shaft. But cylindrical असू शकता आणि square भी shaft असू शकता. Bar असलं तर the external dimension किती आपण they all come under the shaft basis system. So this is a cylindrical, this is the internal means hole, and this is shaft. It's called external. But same, this is a rectangle slot. There is common hole, and rectangle solid bar it is common shaft. Shaft and hole now deviation. Now deviation, it is an algebraic deviation means it is an algebraic difference between the size of its corresponding basic size. The deviation difference from basic size to the corresponding algebraic difference between the size to its corresponding basic size. Like it so deviation is an algebraic difference between the sizes to its corresponding basic size, and it may be positive or negative or zero also. Upper deviation, it is an algebraic difference between the maximum limit of the size and its corresponding to the basic size. Yes, so upper deviation, lower deviation, same. It is an algebraic difference. Algebraic difference na karta mare. Algebraic difference means you are making a minus, subtract karo. Upper limit is the basic size minus karo. Kitne value there is your upper deviation, lower deviation. Same upper limit, lower limit. Equal same thing. But the words are used. It is an algebraic difference between the minimum limit of size and its corresponding basic size. So basic size is very important in every case. Upper deviation is the deviation which gives the maximum limit of size, and lower deviation is the deviation which gives the minimum limit of the size. Actual deviation is the algebraic difference between the actual size and its corresponding basic size. Actually, it might turn. And now this is a very important term called tolerance. Tolerance like the S word. Please attention. This word is throughout to your life you should remember. Tolerance like it is the difference between the maximum limit of size and the minimum limit of size. Correct? So if the tolerance like it is the difference between the maximum limit of size, maximum 20 plus the maximum limit size to the minimum limit of size. So a value it has to be always some value. Correct? Positive value or negative that value it always a positive and is expressed only in number without sign. Okay, value that is your tolerance. But for example, plus 20 plus or minus 0.02 is the tolerance. I said plus or minus 0.02 millimeter is the tolerance. So what is the total tolerance? What is the definition here? Read the definition and tell me what is the tolerance. It has to be value. What is it? Fast. Huh? Yeah, you have to tell me what is this. Plus or minus 0.02. The basic side of sum 29 plus or minus 0.02. Or value what is the tolerance? Explain. No, tolerance. Now, I'm not talking about upper limit, not I'm talking about lower limit. But I'm talking only tolerance. Definition is in front of your screen. Read it, understand it, and tell. Yeah, it's a difference between the maximum limit and minimum. What is the maximum limit there? What is the minimum limit there? Take the minus square. You will get the tolerance. Find out. Alta, you are understanding this language? Alta Mare, this is the engineering language. Alright? Here, very important. Nala, can't find. Dylan, what is the tolerance over there? Tolerance ki ruti ka? Zero, no. You're not understanding. Here you did it. Say 4 times. It's a difference between the maximum limit of size to the minimum limit of size. What is the maximum limit over there? What is the minimum limit over there? Minus it, no? You'll get somewhere.
Sir, 0.19.
0.04, correct. What is the answer? Presley, सर बड़बड़ हमारा क्या जाता है यार लगाने का वो फाइलिंग करने का हो गया काम. What is the tolerance? 0.04. What about you? Tolerance black. Explain कर मगा.
Plus or minus.
This is the I'm not